Hello. Today we're doing module number 1, which deals with the ubiquity of microorganisms. Two important words there, ubiquity and microorganisms. Microorganisms, of course, are life forms that are difficult, if not impossible, to examine without some sort of a magnification. The word ubiquity is a noun and it refers to a particular state of being. It's the state of being that is present everywhere. So when we say that something is ubiquitous, we mean that it is found everywhere. And it is certainly true that microorganisms are really found almost everywhere. Microorganisms are truly ubiquitous. Now, as you read over in the lab write-up that was provided for you, we are going to use agar plates to detect the presence of microorganisms under a variety of circumstances. Before we get into the actual procedure, let's talk a little bit about what agar plates are. What microbiologists usually refer to as an agar plate is a device that uses a petri dish, which is composed of a bottom and a top that fits over the top of the bottom. This is a plastic petri dish. We buy this commercially, and when we receive petri dishes like this, they are sterile. There are no microorganisms, no spores, no viruses, nothing that could be alive or potentially alive is found on the inner surfaces of a sterile petri dish. In order to make this an agar plate, we have to pour a solidifying substance into the bottom section of the plate. We do this, of course, by taking the top off and then pouring a suspension or a solution that is liquid into the bottom portion, put the top on, and then allow that solution or suspension to harden, become solid in the bottom of the plate. Once the substance has solidified in the bottom of the plate, it'll look like this. You'll notice that in the lighting that we have here, the plate in my left hand looks a little bit cloudy, and the empty plate in my right hand is clear with no cloudiness and no color. Again, this is clear and colorless because it doesn't have anything else in it. But if you pour something into the plate, something we call an agar, and the agar solidifies, it usually solidifies and at least appears slightly cloudy. And as I turn the plate on edge, and you can see me taking the top of the plate off, you'll see that there is a layer. If you're looking at the bottom here on it with an edge view, you'll see there's a layer of a substance that we generically refer to as an agar. So there is sterile agar that has solidified in the bottom half of this petri dish. Together, the top and the bottom are usually referred to as an agar plate. In order to do module number 1, we are going to use 5 agar plates. We usually name the agar or the solidified material in the bottom of the plate because that solidified material can be one of many different things. For module number 1, the solidified material, what we're calling the agar, is a type of agar called tryptic soy agar. The name is recorded in the write-up of your module. We usually refer to tryptic soy agar as TSA, which of course would be an acronym for tryptic, which is the T, soy, which is the S, and agar, which is the A. We are going to use 5 plates, 5 agar plates that contain tryptic soy agar. In other words, I'm going to refer to these as TSA plates. And your module would instruct you to label the plates before you use them. I've already done that for you. So here you can see the 5 plates already labeled, already marked up. The top row from left to right is air, touch plate, swab plate, hair plate, and cough plate. You'll notice that the touch plate and the swab plate are additionally labeled by being marked so as to form 4 sections on each of those plates. Whenever we do this, we refer to those sections as quadrants. I went further and I numbered near the center of the plate each of the quadrants, 1, 2, 3, or 4, so as to make it easier to refer to them later on. Now, according to your module, the way you would do this lab is you would take the air plate. All these plates, by the way, are upside down. The bottoms are face up and the tops are down. So if I would pick up this hair plate, for example, and turn it, you would see that the part of the plate with the writing on it is the bottom part, and the top has no writing on it. This is important. Whenever you mark plates, whenever you label plates with information, you never, ever, no, never mark the information on the top. Because if you remove the top from 2 or more plates simultaneously, it's possible you could put the wrong top back onto the wrong plate. So to make sure that you identify your plates correctly, you have to always put the identifying marks only on the outside surface of the bottom portion of the Petri dish, because the agar travels with the bottom. There is no agar, obviously, found in the top. So these 5 plates are currently upside down with the bottoms facing up. Module instructs you to take the air plate, remove the top, put the top aside, and leave the surface of the air plate exposed for 15 to 20 minutes. This will allow dust particles, spores and bacteria perhaps, to just settle or drift down onto the agar if they are in fact present in the air. The second plate is the touch plate. If there were 4 people in your lab group, as there usually would be, each person would be asked to touch a different section. So the first student would put their finger tip and press on in the middle of quadrant 1. Student number 2 would do the same thing in section or quadrant 2. Student 3 would touch quadrant 3. Student 4 would touch quadrant 4. Once all 4 students have each touched a different quadrant, plate is then put back down, upside down, the way we started. The third plate is a swab plate. In order to use the swab plate, we need to have available to us several sterile swabs. When we do lab exercises like the one we're doing today that require swabs, we provide the swabs, sterile swabs, to you or for you. The swabs are bought, enclosed in a sterile paper bag. Sometimes there'll be 2 swabs in a bag. Oftentimes there's only 1. The swabs that we purchase here at Trinity have only 1 swab per bag. this swab is sterile until I open it. Once I open it, it is possible that it will become contaminated. So you never want to open up your swabs until right before you're ready to use them. So let's say we're ready to use them. Again, the swab plate is divided into 4 quadrants. So to do this exercise with the swab plate, you will need to have 4 different swabs, and you're going to touch each swab to a different surface, and then take that swab and rub it against one of the quadrants. So for example, let's say I wanted to do quadrant number 1 on the swab plate. I peel the bag open. Of course, it doesn't open the way it's supposed to. What's new? Remove the swab. You'll notice the end of the bag that was opened was the wooden end. The other end of the swab has the cotton, and so the bag is designed to be open so that you do not have to touch the cotton swab and transfer microorganisms from your fingers to the swab before you're ready to use it. So I'm going to use this swab to transfer material to quadrant number 1 on the swab plate. Let's do the table surface. So I go over here next to the piece of paper. I rub the swab back and forth several times over several square inches of island surface, table surface. I then take that swab, I grab the bottom of the plate. You'll notice I'm going to lift the bottom up and leave the top behind. I then turn the plate, the bottom of the plate over so I can see the surface. I find quadrant 1, and quadrant 1 is right here. I'm going to take my swab and I'm going to gently rub the swab on the surface of quadrant 1. Back and forth. When I'm done rubbing, you don't want to push down hard because the agar is soft. It's like Jell-O. Once I'm done, I pull the swab out of the way. I put the bottom of the plate upside down back inside the top so it's no longer exposed to the air. And then I will find a disposal container, like this incredibly clean one right here. Obviously, it's been used a lot. And I will throw the contaminated swab into that bucket, to that container. Anything that has been contaminated while used in the microbiology laboratory needs to have a place to be disposed of. In this case, contaminated swabs are thrown away, disposed of in a plastic container similar to this one. Now there are 3 more quadrants that need to be swabbed. I'm not going to do all 4 of them for you right now, but I will do a second one since the first swab I opened didn't open up very well. So when you look at this bag, my left hand, my left thumb and finger are on the swab end. My right thumb and finger are on the wooden end. I separate this end of the bag, I carefully peel it apart, hopefully do a better job this time. And it's working pretty well. This time it worked. I peeled it back about a third of the way. I'm going to grab the wood with my finger. I'm going to grab this end of the bag with my other hand and pull the swab out. By doing that, the cotton swab only touches the sterile inside of the bag. It is still sterile. So now I need to touch or swab another surface. Maybe for this one, get the light just right. So I'm going to go back and forth numerous times, pressing against the surface. Once I've done this for 10 or 15 seconds, so hopefully I've picked up about anything that would be there. I then take that swab, I grab the swab plate again, I lift the bottom up, I turn it right side up so I can see the surface of the agar. This is swab number 2. So I am going to swab surface number 2 right here. This is quadrant number 2. I'm done. I remove the swab, turn the bottom of the plate upside down again, and replace it into the lid or the top. Again, I find an exquisitely clean bucket. I throw the swab into there, and I have finished the second swabbing. Again, I'm not going to do all 4 for you. I just want to demonstrate how it's done. You would take 2 more swabs. You would rub another surface with the swab, and then put it in quadrant 3. Get a 4th swab, rub that against the 4th surface, and then transfer or rub the swab against surface or quadrant 4. So we have finished 3 plates. We've got the air plate that is still open. We have touched 4 different people have touched the touch plate. We have sampled 4 different surfaces and swabbed them onto the swab plate. We're left with the hair plate and the cough plate. The hair plate, what we would ask students to do is to pull out a couple or 3 of their own hairs and then put the hairs, take the bottom up so the surface of the agar is facing up, and then lay the hairs down on the agar surface. So especially the hair follicles would be in contact with the agar. That's really a good place to find organisms, would be in the hair follicle. Once you've done that, make sure that the hair is sticking to the agar so it doesn't just fall off. Then you turn the bottom upside down again and put it on the top, and you're done with the hair plate. The 5th plate is the cough plate. Any one of the students in the group can take this plate, lift the bottom up, turn it over so the agar surface is right side up and exposed. Then I'm going to do this off camera, but what you'll be able to hear me, what they would do is take the plate, hold it about 5 or 6 inches away from their mouth, and then cough a couple of times onto the surface of the plate. Once you have done 2 or 3 coughs, you will then take that plate, turn it upside down, and replace the bottom to the top. You can set these 4 plates aside because you're going to finish, you would normally have finished these well before the air plate was ready to be covered again. And after 15 or 20 minutes, eventually you would be ready to cover the plate, the air plate. So you would take the cover that you set aside, the air plate, you put it back on top of that bottom, you turn the plate upside down, and you have finished today's portion of the exercise. All that remains to be done is to put these plates in an environment where the organisms, if they are on the agar, can grow. Normally what we would do is we would take the air plate, the swab plate, and the touch plate, and we would probably put all of those in a lab drawer so they could incubate, grow at room temperature. The cough plate and the hair plate, we either could put those in the drawer, we've done that before, or we might put them into an incubator, which is nothing more than a fancy oven. An incubator. Why would we use 37 degrees C? Well, 37 degrees C is equal to 98.6 degrees Fahrenheit. And as hopefully most of you would recognize, 98.6 degrees Fahrenheit is considered to be a normal body temperature. And so any organisms that might be associated with our bodies, certainly the inside of our bodies, like microorganisms that might be found in our secretions found in our mouths and noses, or the organisms that might be found at the bottom of a hair in the hair follicle, those organisms, if they're present, probably grow better at body temperature, 98.6 degrees Fahrenheit or 37 degrees C, than they would in a drawer at room temperature. So what I'm going to do is take these 3 plates, the touch plate, the air plate, and the swab plate. I take these 3 plates, put them in the lab drawer, let them incubate at room temperature for a few days, while I'm going to put the cough plate and the hair plate in the 37-degree incubator and see what happens there. Let those plates sit at 37 degrees C for at least a couple or 3 days. That concludes our lab. Goodbye.